Hey everyone, this is Mr. K, and today we are going to review how to use our unit circle to find the sine, cosine, and tangent of any of the angles that are on this unit circle. So first you can tell my unit circle's got both degrees and radians in it. Remember that the unit circle is just a circle that has a center at the origin and a radius of 1, which is why you can see like the coordinates here are 1, 0. Coordinates up top here be 0, 1, because it's just like your typical XY coordinate plane. Also, keep in mind that most of the time, most of your math classes will have you commit this to memory, so just something you got to memorize. So first, where all these values come from are actually from these special triangles. Like if I were to draw a right triangle out of this, I would make a 30, 60, 90 triangle, and that helps me get these values because my hypotenuse would be equal to 1. So that's kind of where all these coordinates come from, is using those special triangles to find these coordinates. But these coordinates are incredibly helpful because they are the sine and cosine of these angles. So for example, if I wanted to know the sine of 30 degrees, the sine is always going to be the y value. So any of these coordinates that you see on here, the sine of that angle is always going to be equal to the y coordinate. And then the cosine of that angle is always going to be equal to the x coordinate. And just to prove it to you, I have my calculator here. If I make sure that I'm in degree mode here, I know it looks a little blurry here. Let's see if we can focus. So now if I type in, I see my 30 degrees, sine should be 1/2, and so then when I type into my calculator sine of 30 degrees, I end up with 1/2. And just to prove to you, the cosine is the x value. If I type in cosine of 30 degrees, I get that decimal, but now if I type in the square root of 3 divided by 2, I end up with the same decimal, so that's how I know that those are in fact equivalent. So every single y value or y coordinate in this circle is a sine of that angle, and every single x coordinate is going to be the cosine of that angle. Now, what about tangent? Tangent of that angle is always going to be equal to the y value divided by the x value. And an easy one that we can look at is right here is 45 degrees, because since the x and y value are the same, I should expect that the tangent of 45 degrees should be equal to 1. And sure enough, when I type that in, press enter, I get a value of 1, so that's how I know that's true. If you ever forget this setup, there is something that you can do, which is actually just make a triangle out of this. So if I set up my triangle, I know that my radius was my hypotenuse, which is 1. And then looking at this triangle, I know that the y-axis goes vertically, so that this is going to be my y. And then I know that x-axis goes horizontally, so this will be my x. And now if you use SOHCAHTOA, it should come out to be exactly what we got up here, where the sine of that angle would be opposite divided by hypotenuse, so that would be y over 1, which is just y. The cosine would be adjacent over hypotenuse, so that'll be x over 1, which is just x. And then the tangent of that angle is going to be opposite divided by opposite divided by adjacent, which would be y divided by x. And so you can use this unit circle to find any of the sine, cosine, or tangent values of that angle. So just to kind of give you another example, if I type in the sine of 270 degrees, I should get -1. So just to confirm, again, let's do sine of 270 degrees, and you end up with -1. So this is going to work for any of these angles that you use that you have on your unit circle. It's a really helpful, fast way to find those values. So I hope this video was helpful. Thanks. Have a great day.